Alright, so yesterday we talked about writing chemical equations, and we were talking about the subscripts and how we put the subscripts on the elements to get the total charges of the compounds or molecules to get balanced out. So now that we got those little letters there, now we're going to assign what's called a coefficient to these chemical reactions in order to get them to balance out. Now, when we're balancing equations, we got to remember what's called the law of conservation of mass. So whatever we put in, we have to get the same amount out. So let's look at this first equation that we have, okay? We're going to have one zinc going in, and we're going to have one zinc coming out. So that one is already balanced out, that specific element. So we have one H going in, we have two H's coming out. So we're going to have to put a 2 in front of this, okay? In front of the hydrochloric acid. So now we have two H's. We have two Cl's going in. We have two Cl's coming out. So this equation is now balanced just by adding a 2 in front of the hydrochloric acid. So that takes us on to number 2, which is potassium chlorite yields potassium chloride plus oxygen gas. So again, let's start with the first letter and let's go through it. So we have one potassium going in. We're getting one potassium out. So far, so good. We've got one chlorine atom going in, one chlorine atom coming out. Okay? So here's where it gets a little tricky. We have 3 oxygen molecules coming in, but we only have 3 of them coming out. So what we have to do is we have to do what's called a least common factor, which you just multiply the 2 together. 3 times 2 equals 6. So we're going to get everything to 6. So an easier way to do this is just to put a 2 here. 2 times 3 is 6. 3 times 2 is 6, and then you're going to have to put a 2 here because, again, you have 2 potassiums, so you got to have 2 potassiums. So everything now is balanced. Another way to do this is if you think about how we've been flipping the charges of like the pluses and the minuses, you can do the same thing. You can put the 2 on that one, the 3 on that one. It balances out the same way. So that's going to take us down to number 3. This one is a little bit trickier, because now we're dealing with polyatomic ions. Okay, so let's start with the very first one again. We're going to have 2 irons going in. We're only getting 1 iron out. So the first thing we're going to do is we're going to put a 2 in front of this set of letters. We've got 3 SO4s. You're going to treat these SO4s like a one entity. Okay, so go ahead and put parentheses around them. Go ahead and put parentheses around these OHs because they're one thing. They're the same thing. You can't separate them. So we got 3 SO4s. We only have 1 SO4 here. So let's put a 3 in front of this set. So that's going to balance out our iron and our sulfate. So let's look at our potassium. We have 1 potassium coming in. We have 6 coming out because we have 3 times 2. So since we only have 1 here, let's go ahead and put a 6 here, which is going to give us 6 potassiums going in, and it's going to give us 6 potassiums coming out. And we have 3 OHs. Then we have 2 here. So we got 2 times 3, which gives us a total of 6 OHs coming out, which means everything is balanced. And we can move on to number 4. Number 4 is the hardest one you're going to have to do. 5 and 6 are very easy. Number 4, again, is going to be the hardest one we're going to do today. If you can do this one, you can do any of them. So we're going to have 2 carbons going in and only get out 1 carbon. So right away, let's go ahead and put a 2 here. Get our carbons balanced out. A lot of this process of balancing equations is just going to be trial and error. You're not going to get it the first time. You might not get it the second time, but you'll eventually get to it, and you just got to keep replacing numbers until you get the same number going in as you do the same number coming out. So we got 2 carbons in, 2 carbons out. We got 6 hydrogens going in. We only got 2 coming out, so let's put a 3 here. So now this part is balanced. So here's where it gets really, really tricky, because we're going to have 2 oxygens going in, and then we have 4 here, and we got 3 here. So we got 2 going to 7. Okay, so we got to do the least common factor again, which you multiply those 2 together. Least common factor of 2 and 7 is going to be 14. So you can just flip these letters. You're going to put 7 here, and you're going to have to double everything on this side. Okay, you got to get this to 14. You only got 7. You got to get all these to 14. So let's mark out this 2, change it to a 4, mark out this 3, change it to a 6. Since we doubled this side, if we think back to algebra, if you change one side, you got to change the other side. Since we doubled this, we got to double this. So let's put a 2 here. So now we have 4 carbons coming in, and we have 4 carbons coming out. We have 12 hydrogens going in, and we're going to have 12 hydrogens coming out. We got 14 oxygens. We're going to have 8 here, and then 6 here. 8 plus 6 is always going to be 14. So 14 going in, 14 coming out. Again, this was the hardest one, so if you can understand this one, you can understand balancing any equation that we do the rest of the year. So let's go down to 5 and 6. 5 and 6 are very, very simple. Look at 5. We've got 2 hydrogens. 2 hydrogens that are going to be coming in right here. We only have 1 coming out, so let's put a 2 here. We've got 2 Cl's, 2 Cl's, balanced, good to go. All you have to do is add that 2. Number 6, we're going to have H2SO4, which is sulfuric acid plus calcium carbonate, yields carbonic acid and calcium sulfite. So let's start with this hydrogen here. We've got 2 hydrogens going in. We got 2 hydrogens coming out. The hydrogens are taken care of. And let's go and put parentheses around these polyatomic ions just to make it easier. We got 1 SO4. 1 SO4 coming out. We're good. We got 1 carbonate going in. We got 1 carbonate coming out. Everything is balanced. All you have to do on this is write already balanced. Hope this helped you today. Again, this was just a very quick example of how to balance equations. The next page is several pages in your packet. I think there's 4 pages total of balancing equations. We're going to work on that the rest of the week. So it's obviously going to be a big part that you're going to need to know. So if you have any questions, please make a note of them, and I will answer them for you when I come back on Thursday. Thank you, and as always, have a great day.